Hello, in this video I'm going to solve the problems given in quiz 1. The first question, a polynomial is given to you and you're supposed to factorize this polynomial and write your answer down here in this empty space. Okay, the first thing comes to mind is that you see that there are some common factors between all the terms in this polynomial, and I have already told you in the lesson that whenever you can factor some terms out from all the terms in the polynomial, that has the priority over all other methods. So what we do here, let me just write this down here in front of our eyes. H squared x squared plus 49 hx cubed. So I pull a factor of h out, I pull a factor of x out, and what is left is h squared plus 14 hx and then plus 49x squared. Let us double check that. When I take this one and multiply it back here, I will get the first term, so that's correct. If I take this one and multiply it here, I will get the second term, that's also correct. And finally, if I take this one and multiply it here, I will get the final term, which is also correct. But if you stop here, even though this is partially correct, but it is not complete, because the expression in the pair of brackets can be factorized more using the squaring rule. So that's important to do it as well. So this becomes hx, the copy and paste of the first part, and then I would write h plus 7x to power 2. Let us double check. If I ask you to expand this, you would say the first one squared, which gives me this one, 2 times the first one times the second one, which gives me the second term, and finally the second one squared, which gives me the last term. So what I have done is correct. So this is the answer to this problem. And what I expect you to write in the empty space is hx and then h plus 7x, and then type this character here and then put 2. So that's the answer to the first question. Okay, now let us go to the second question. Here, a rational expression is given to us and we are supposed to simplify it and write it in its simplest possible form in this empty space. So you remember hopefully from the lesson that if you want to simplify a rational expression, you have to factorize the numerator and the denominator as much as is possible and then find the common factors from the numerator and the denominator and simplify them out. Okay, so let us just do that. So if you don't mind, let me write the question here. Okay, before writing the question here, I can immediately factorize that. Okay, so you see that this expression is a squaring rule. So let us write it as x minus 1 squared. Let us double check. The first one squared is this one. 2 times the first one times the second one is minus 2x. And finally, the second one squared is 1. So what I have written here is correct. And hopefully you realize that the denominator follows the conjugate pattern. So I factorize it using the conjugate rule. If I factorize it, it becomes 1 plus x times 1 minus x. Okay, so here you have to be careful. Of course, you can simplify this with that. And then you see that this is 1 minus x, this is x minus 1. Okay, so if you understand that there is no difference between x minus 1 to the power of 2 and 1 minus x to the power of 2, because this power of 2 is even, and x minus 1 and 1 minus x are just opposite. But if I have two opposite numbers and raise them to an even power 2, the answers will be the same. So if you recognize that immediately, then you can simply write it like this. You can write it as 1 plus x to power 2. Instead of x minus 1 to power 2, you can write 1 minus x to power 2 and then divided by, oh sorry, I don't know why I did put this power of 2. There is no power of 2 here, of course. And then what I do, it becomes 1 plus x and then 1 minus x. And then you see that this 1 plus x and that 1 plus x are gone. 1 minus x and one of them are gone. And what is left for me is 1 minus x. Okay. If you are not comfortable with this method, so the answer that you have to provide in this box is 1 minus x. Of course, you can see that this is also minus x plus 1. there is no difference between 1 minus x and minus x plus 1. Both of them are correct. If you're not happy with this method, so you can do it like this. You can say that 1 plus x, let me start from here again, and then instead of x minus 1 to power 2, I write x minus 1 and x minus 1. And in the denominator, I have 1 plus x, so I write it down. And if you remember in the lesson, I told you that whenever you need a minus b, but you have b minus a, the trick is to factor a minus sign out. So here I have 1 minus x. In order to be able to simplify it with the numerator, I need it in different order. I need it to be x minus 1. Okay, so this motivates me to factor a minus sign out, and instead of writing 1 minus x, write x minus 1. That's also another way to see the same problem. And now what happens, this x plus 1 and this 1 plus x are gone. This x minus 1 with one of them are gone, but remember there is a minus sign left here and there is x plus 1, x minus 1 left there. So what I do, I would write x minus 1 in the numerator and minus 1 in the denominator, which if I multiply the numerator and the denominator by a minus sign, the numerator becomes 1 minus x, the denominator becomes 1, and then finally the answer becomes 1 minus x. So it doesn't matter how you think about the problem. If you do it correctly, you will get the correct answer, 1 minus x. Okay, now let us go to the next problem. So here it's a division. We want to simplify it as much as possible, and division of two rational expressions. There are two things that you need to remember. You have to factorize all the numerators and denominators involved in that problem, and then you have to transform division to multiplication, but the price that you pay is to write the reciprocal of the second fraction, meaning that you have to interchange the numerator and the denominator. Okay, so let me be patient and do it in step by step. Okay, so what I do, I copy and paste the first fraction as you see there. Okay. And then what I do, I change division to multiplication, but then I write the reciprocal of the second rational expression, meaning that I put the denominator in the numerator and put the numerator in the denominator. Okay, then I start fully factorizing all these expressions. So here you see immediately x is in common, so I have to factor x out. Then of course I have to think what else I need to do, if any. So this becomes x squared minus 6x plus 9. You can always double check, multiply this back, you will see that I get the same expression. And in the denominator, what I have is x plus 2. And in the numerator of the other one, I can factor a 20 out, then x plus 2 is left. Oops, I have written this only 15. The answer is 15x. So see, this is 15x. I wrote it wrongly first. Okay, now what happens here, I have 5 and x in common, so I factor a 5x out. What is left is x minus 3. But of course, be careful. This is still not fully factorized because that's a squaring rule. So let me just be patient and do it one more step. I write x, and then instead of a pair of brackets, I write x minus 3 to the power of 2, and then I have x plus 2, then multiplied by 20, x plus 2, and finally 5x, x minus 3. Okay. So now you remember from the lesson that you can simplify vertically. You can also simplify in cross manner way. So what we can do now, here I can simplify this x with that x. So 1 is left here, 1 is left there. This x plus 2 and that x plus 2 are gone. So 1 is left here, 1 is left there. And x minus 3 and one of these are gone. So 1 is left here, x minus 3 is left in the numerator. And now here, vertically, I can simplify 5 to 5 1 times, 20 to 5 4 times. Now if you look here, what is left is 1, x minus 3, 4, and 1. So if you multiply these expressions, it becomes 4 times this expression. So I write it in the numerator. x minus 3, and at the denominator just 1 times 1 times 1 times 1, which is 1. And of course you can write it as 4x minus 3 here. If you write this expression here, I accept it from you, but I myself prefer to continue and open up the pair of brackets, so it becomes 4x minus 12, and then 4x minus 12 is the answer that I provide here. Okay, let us now go to the next question. Let x be such a number that satisfies this equation. We want to know what is 4x plus 1. Okay, in order to know what is 4x plus 1, first I need to find x. And when I found x, I put it here and calculate that number, and whatever that number is, I will write it down here. But you know that we have solved these type of questions in the lesson a lot. If you want to solve that equation, you need to multiply both sides by LCD of all the denominators. But of course you see that this denominator can be factorized simply, and that's a very simple standard factorization, hopefully by the experience that you learned from the lessons. You immediately can factorize this. So you put two x's here, and you ask yourself, I need two numbers whose sum is positive 1 and the product is negative 6. And then immediately you can find those two numbers. One of them is positive 3 and the other one is negative 2. So let me rewrite the equation with the factorization of the last fraction considered. Okay, so 2 over x minus 2 plus 4 over x plus 3 is equal to 1 over, instead of that denominator, I just put the factorized for x plus 3 and x minus 2. Okay, so immediately you realize now what is the LCD. The LCD of all denominators is just the last denominator itself. Okay, so what you have to do, you have to multiply the left side and the right hand side by this LCD. So for completeness, let me write it down. Yes, and then on the right hand side the same thing. X plus 3, x minus 2. Yes? Okay. Now what you do, you take this one and multiply it here. But when you multiply it here, this one and that one are gone. This one and 2 are left, so you multiply them. So it becomes just simply 2 times x plus 3. And then you take again this one and multiply it here. But then this one and that one are gone. 4 and x minus 2 are left. You have to multiply them. So it becomes plus 4x minus 2. And on the right hand side, everything is more or less gone, yes? Because this one and that one are cancelled, this one and that one are cancelled, and you just get 1. And this is extremely simple equation to solve. So let me expand that. So I multiply 2 in, 2x plus 6. I multiply 4 in, 4x minus 8. And then it becomes 1. 2x plus 4x is 6x. And then 6 minus 8 is minus 2 is equal to 1. So then what happens? 6x is 3. So this means that x is 3 over 6, which is 0, 5. But of course, be careful. This x is not wanted in the problem. And by the way, is this x 0.5 acceptable or is a false root? We see that this is acceptable because it doesn't pose any problems for the denominators. This denominator vanishes if x is equal to 2, and this denominator vanishes if x is equal to minus 3. The same story here. And 0.5 is neither a 2 nor a minus 3, so it's an acceptable solution. Okay, so then what is 4x plus 1? X, we got it to be 0, 5 and then plus 1. But 4 times 0, 5 is extremely simple. It's just 2 and then I have 1, so it becomes 3. So the answer that I expect you to write here is just simply 3. Okay, let us go to the next question. In order to simplify this expression, I have one fraction multiplied by another fraction, and I want to know the answer. Okay, but of course you see that this is the sum of two terms. So what I do, I first do this sum, I do this difference, and then I get two fractions and then multiply them, because the pair of brackets prioritize this addition and this subtraction. So I cannot start with multiplication directly. I have to do this one and that one, and when I found the answers, then I multiply. That's the meaning of pair of brackets. Okay, so what I do, I want to do the first one. Okay, so here the denominator is 1 because it is not written, so the LCD between this one and that one is just a squared plus b squared itself. So instead of 1, I write a squared plus b squared over a squared plus b squared. Okay, the reason I did that because I want to take the common denominator between this one and that one. So this is exactly 1. So instead of 1, I wrote this so that the denominator here and the denominator here match, and then I can add. Okay, so it becomes, I copy and paste the second fraction, 2ab over a squared plus b squared. Okay, this is the first step in the first one. Now let us do something similar for the second pair of brackets. Again, instead of 1, I have to write it in a way that the denominator of this one and the denominator of that one match. Okay, so that's exactly clear. So I would write it as a plus b to the power of 2 divided by a plus b to the power of 2 minus 2ab. I copy and paste the second fraction, a plus b to the power of 2, and then that's it. So that's the first step. So I'm preparing myself in both pair of brackets to be able to do this addition and this subtraction. Okay, now everything is ready in the first pair of brackets. So that is my common denominator. I write it once and then I add the numerators. Okay, so what happens? So this becomes equal to the denominator here is a squared plus b squared. The numerator of the first one is a squared plus b squared plus the numerator of the second one is 2ab. And I don't need any pair of brackets from now on. Yes, so I put the multiplication. The second one is also what? A plus b to the power of 2 as a denominator. The numerator of the first one is a plus b to the power of 2 minus the numerator of the second one is 2ab. Okay, so what happens now? So do you remember, if you want to simplify multiplication, you have to factorize the numerator and the denominator. Here you know that this cannot be factorized, but here this is already factorized for, but this is also a famous pattern. So I factorize this, but here I have to open the first pair of brackets to see if that I can simplify and then factorize. So what we do for the first one, I just simply write a plus b to the power of 2. So let me explain again. Instead of this expression, I wrote its factorized form. Why is that correct? Because the first one squared is this one, the second one squared is this one, 2 times the first one times the second one is that one. And the denominator is of course a squared plus b squared. Yes? Multiplied by. For the denominator of the second one, I just write this one, but then hopefully you realize that this expression here can be written as a squared plus 2ab plus b squared. And then what happens? This 2ab here and that 2ab there are gone. So what is left is a squared plus b squared. That's exactly what I will write down there. So this becomes a squared plus b squared. Okay, now I want to multiply these two fractions. Can I simplify vertically? No. Can I simplify vertically? No. But you see that I can simplify in cross-manner way, this one with that one and that one with that one. So actually just one is left, because when I simplify this one, that one is 1, this one and that one 1. So the answer becomes just 1 over 1, or simply 1. So what I expect you to write in this space is just simply 1. Okay, now the final question. We are supposed to add and subtract, of course, these fractions. The rule is, we had it in the lesson, we have to fully factorize all the denominators. So here I pull a 3 out, here this is a conjugate rule, and here I pull a 2 out. So let's see how it goes. So the expression is equal to, For the first one, I copy the numerator. In the denominator, I factor 3 out. It becomes x minus 1, and then minus the numerator is x. The denominator is the conjugate rule, so it becomes x minus 1, x plus 1. And finally, the last one, I factor a 2 out, so it becomes x plus 1, and then I have 1 there. So if you look at here, LCD of all the denominators is equal to, I want an expression which is divisible by this, by that, and by that simultaneously. So I have a factor of 3 and 2 there, so to take care of the numbers, I put a factor of 6. 6 is the smallest number which is divisible simultaneously by 3 and 2. And for the expressions, of course, hopefully it is clear for you, x minus 1, x plus 1 is the expression. Okay, so that is your LCD. So what you do, you rescale all these fractions in a way that the denominator of all of them be this LCD, and then rescale the corresponding numerator appropriately. So what happens here, so the first one, so if you don't mind, let me write it here so that I have more space. So the first one is, the denominator is 6, x minus 1, x plus 1. Then I ask myself, how is that this one has transformed to this one? By multiplying it by 2 and x plus 1. So I have to do the same thing in the numerator. I will take the numerator and multiply it by that one. So it becomes 4 times x plus 1. Okay, after that you see a minus sign. So I put it there, and then the common denominator is again as before, the same LCD. And then you have to ask the question again. Your denominator was x minus 1, x plus 1. Your new denominator is 6 times x minus 1, x plus 1. So what has happened? The numerator is being multiplied by 6. So you have to multiply the numerator by 6. So it becomes simply 6x. And then after that you see a plus sign. So you put a plus sign and you put your LCD here. And then ask the same question. The denominator was this, now the denominator is this. So what has happened? You can immediately see that the denominator is being multiplied by a factor of 3 to make it 6, and by a factor of x minus 1 to make it 6x minus 1, x plus 1. So you have to take the numerator and multiply it by the same factor, which becomes 3x minus 1. And now that all the denominators are the same, so you write a common denominator, and then you start adding this, you take this one minus that one plus this one, okay? So it becomes 4x plus 1 minus 6x, and then plus 3x minus 1. So let me clean, we don't need that long one. Okay, and then what you have to do, if you remember in the lesson, I told you that never touch the denominator, but try to simplify the numerator as much as you can. So I don't touch the denominator, I leave it in factorized 4, and I start opening up the numerator by multiplying 4 here and there, by multiplying 3 here and there. So this becomes 4x plus 4 minus 6x plus 3x minus 3. And if you continue, 4x plus 3x is 7x minus 6x is just simply x. And then what you have 4 minus 3, which is just plus 1. And then you see that this is the reason that I tell you that don't simplify, don't multiply the denominator, because you now realize that, okay, this x plus 1 and that x plus 1 can be simplified. So 1 is left in the numerator, and 6 times x minus 1 is left in the denominator. But you see that in this form, none of these options are correct, but immediately you realize that you can keep the numerator and multiply 6 in. So the answer becomes 6x minus 6. Okay, and then if you see, this answer is the correct answer. Okay, so I hope that this video was useful for you. I really recommend you, if you have been absent for this, try to follow the video on your own. Whenever you see the question mark, do not see my solution. Pause the video and try to solve the problem yourself first, and then continue watching the video to confirm that if your answer is correct, or if you get stuck in the middle, at least you learned when I explain the question for you. Okay, until the next video, be safe and goodbye. Thank you.